Good morning, children. Today we are going to study about similar triangles. What are similar triangles and what are the criteria for two triangles to be similar? Before moving to similar triangles, let's revise what are congruent triangles. Congruent triangles we have studied in 9th standard. Two triangles are said to be congruent if they have same shape and same size. Means if one triangle can completely superposed upon the other triangle, then the triangles are said to be congruent. In the case of congruent triangles, all the corresponding angles are equal and all the corresponding sides are also equal. And we have also studied different criteria for the similarity of triangles. That was AAS similarity, two angles and any one side of one triangle equal to two angles and one side of the other triangle. And RHS congruence, it is right angle hypotenuse and one side of triangle equal to a right angle hypotenuse and one side of the other triangle. Then SAS congruence is, what is SAS? ASA congruence is two angles and included side of one triangle equal to two angles and included side of the other triangle. And SSS congruence, three sides of one triangle are respectively equal to the corresponding three sides of the other triangle, then the triangles are congruent. Then last one, SAS congruence, two sides and included angle of one triangle equal to two sides and included angle of the other triangle. Then also triangles are said to be congruent. Like that, these 5 congruent criterion we studied in 9th standard. So if any two triangles satisfy any one of these criterion, we can say the triangles are congruent. And in the case of congruent triangles, remember, congruent triangles are triangles having same shape and same size. That's very important. And see what are similar triangles. Similar triangles are also triangles with the same shape, but the size can be different. In the previous figure, we have seen all the triangles are having same size, isn't it? But here you see, this is comparatively bigger and this is smaller. Here it is bigger, this is smaller, bigger, smaller. So triangles having same shape, but the triangles can be of different size. These type of triangles are called similar triangles. And if the triangles are having same size, then also triangles are similar. Okay, all congruent triangles are similar, but all similar triangles are not congruent, because all the similar triangles doesn't have the length of sides equal. So as in the case of congruent triangles, similar triangles are also having some similarity criterion. Okay, the first similarity criterion is AA similarity criterion, or it can also be known as AAA similarity criterion. We will be explaining that. And second one is SSS similarity criterion and SAS similarity criterion. Like this, 4 similarity criterion are there. First one is AAA, next comes AA similarity, then SSS similarity, then SAS similarity criteria. Let us say that one by one. Before that, let me say once again, what are similar triangles? Triangles with the same shape but different size are called the similar triangles. See the first similarity criterion. It is AAA similarity criterion, isn't it? What is AAA stands for? Stands for the 3 angles of a triangle. Anyway, similarity criterion is for, here we are explaining for the pairs of triangles with the same shape. Okay, here triangle ABC and triangle PQR are having same shape, but they are of different size. In this figure, let us see angle A is equal to angle P angle B equal to angle Q and angle C equal to angle R. They are given same color. Equal angles are given same color in the figure. See, angle A equal to angle P, angle B equal to angle Q and angle C equal to angle R. Then we can say triangles are similar. This is a symbol for similarity, this one. And we are using this symbol for congruence and simply this curved line. That is the symbol of similar. So we can say triangle ABC similar to triangle PQR. So what is a similarity criterion? Two triangles are said to be similar if the three angles of one triangle are equal to the corresponding three angles of the other triangle. If three angles of one triangle are equal to the corresponding three angles of the other triangle, then the triangles are similar. If the triangles are similar, we can say the sides are in the same ratio. That's very important. In the case of congruent triangle, sides are equal. Corresponding sides were equal. But in the case of similar triangles, corresponding sides are not equal. Ratio of the corresponding sides are equal. See, here AB, its corresponding side is PQ. BC, its corresponding side is QR. AC, its corresponding side is PR. Ratio of the corresponding side means AB by its corresponding side PQ, BC by its corresponding side QR, AC by its corresponding side PR. So, ratio of the corresponding sides are equal. That means AB by PQ equal to BC by QR equal to AC by PR. If these two were congruent triangles, then we will be writing AB equal to PQ, BC equal to QR and AC equal to PR in the case of congruent triangles. But in the case of similar triangles, AB by PQ equal to BC by QR equal to AC by PR. And how do we take the corresponding sides? How can we understand AB? Its corresponding side is PQ, and why we are not taking its corresponding side as QR? How to find the corresponding side? Here you see, this is angle C equal to angle R. This green colored marked angle, its opposite side. These two are corresponding angles. Okay, so certainly the side opposite to these two angles will be corresponding sides. So AB by PQ. Similarly, red color angle A equal to P. Its opposite side of angle A is BC. BC by opposite side of angle P is by QR. Then this blue colored angle. Blue colored angle B equal to angle Q. Opposite side of angle B is AC. Opposite side of angle Q is PR. So, while selecting the corresponding sides, we have to check the angle. So, first to find out the equal angle, then the sides opposite to those equal angles will be proportional. So, say, listen, what are similar triangles? What is a similarity? Triangles are said to be similar if the three angles of one triangle are respectively equal to the three angles of the other triangle. See this example. In triangle ABC and triangle DEF, angle A is 70, angle D is 70, angle B 30, angle E 30, angle C 80, angle F 80. So these three pairs of angles are equal. So we can say triangle ABC similar to triangle DEF by AAA similarity. The second example you see, angle A equal to angle M. Angle B is not given as 90 degree, it is marked as 90 degree. Angle B equal to angle N. Angle C equal to angle O. Both are 60 degree. Here A and M are 30 degree. B and N are 90 degree. So in this case also the three pairs of corresponding angles are equal. So the triangles are similar. So the first criteria for the similarity of triangles is AAA similarity. Let's see now what is AA similarity. Actually, AA similarity and AAA similarity are same. How they are same? See, we can say two triangles are similar if the two pairs of corresponding angles are equal. AA similarity says no need of the three corresponding angles to be equal. We should be able to find out the two pairs of corresponding angles equal. Then the triangles will be similar. Here angle B is equal to angle Q, angle A equal to angle P. Since then we can say the triangles are similar. If the triangles are similar, the corresponding sides will be proportional. In the case of congruent triangles, if we proved the triangles are congruent by CPCT, very familiar word. By CPCT we can say the corresponding sides are equal. Similarly, if the two triangles are similar, being the sides of similar triangles, sides will be proportional. What I mean is, if triangle ABC is similar to triangle PQR, here we can prove ABC similar to PQR because these two pairs of angles are equal. If they are similar, then we can write angle C equal to angle R also. Moreover, we can write AB by PQ equal to BC by QR equal to AC by PR. And how do we take the ratio of the sides? How can we say AB equal to, AB by PQ? How we should take this ratio? How can we understand AB and PQ are to be taken? Here these two angles are equal. How these two angles are equal? By angle sum property. If the two pairs of angles are equal, automatically the third pair of angle also will be equal. That is why I told in the beginning AA similarity is same as AAA similarity. Okay. So remember, if two triangles are similar, if you are able to prove two triangles similar by AA similarity, then automatically being the corresponding angle of the similar triangle, the third angle will be equal, and moreover the corresponding sides will be proportional. See an example. Here triangle PQR and triangle XYZ are similar because angle Q is equal to angle Y 70 degree, angle R equal to angle 60, Z, angle R equal to angle Z 60 degree. So since the two angles are equal, triangle PQ are similar to triangle XYZ. Okay. So if we want to prove two triangles are similar, it's enough to prove two pairs of those triangles are equal. Okay. Next similarity is SSS similarity. What is SSS congruence? SSS congruence theorem is in a triangle, two triangles are said to be congruent if the corresponding sides of if the three sides of one triangle are respectively equal to the three sides of the other triangle. Means if it is triangle ABC and triangle PQR, if it is SSS congruence, we can say if we want to prove these two triangles are congruent by SSS congruence, so AB will be equal to PQ, BC equal to QR, AC equal to PR. Then we can say triangles are congruent. But in the case of similar triangles, we have to take the ratio. Means if AB by PQ equal to BC by QR equal to AC by PR, then triangles are congruent. Triangles are similar. What is SSS similarity? By SSS similarity, two triangles are similar if the corresponding sides are proportional, if the ratio of the corresponding sides are equal. See this example, it will be clear. Here triangle ABC, triangle MNO. AB equal to 10, BC 6, AC 14, MN 5, NO 3, MO 7 centimeter each. And see the ratio. AB by MN is 10 by 5 equal to 2. BC by NO equal to 6 by 3 equal to 2. And AC by MO equal to 14 by 7 equal to 2. See, these three ratios are equal to 2. So we can say AB by MN equal to BC by NO O equal to AC by MO. Ratio of the three sides are equal. So we can say the triangles are similar by SSS similarity. Here is an example also. Sorry. This is an example. So what is SSS congruence also mentioned at right side. If it is SSS congruence, three pairs of sides will be equal, not the ratio. Sides itself will be equal. In the case of similar triangles, a ratio of the sides will be equal. So if you want to prove triangles are similar by SSS similarity, we have to find the ratio of the corresponding sides and check whether they are equal. If the ratio of the corresponding sides are equal, then the triangles are similar. Then comes SA's similarity. See what is SA's congruence. SA's congruence, you can see here, triangles are congruent if two sides and included angle of one triangle equal to two sides and included angle of the other triangle. Means two sides must be equal. Two sides must be equal. Here also these two sides are equal. These two sides are equal. And angle between them also must be equal. Angle included in between them also must be equal. It says congruence means sides equal. And it says similarity. Can you guess what it will be? See, as in the case of congruent triangles, angle must be equal. In triangle ABC and triangle PQR, one angle should be equal. So, it is shaded here, angle B equal to angle Q. And if it is SA's congruence, we will be telling AB equal to PQ, BC equal to QR. We will be telling so. But in the case of similarity, what it is? Angle B equal to angle Q. Then the ratio of the sides including the angle must be equal. So AB and BC are the sides including the angle in the first figure. PQ and QR are the sides including the angle in the second figure. Second triangle. So angle B equal to angle Q. Then ratio AB by PQ. AB of the first triangle by PQ of the second triangle must be equal to BC of the first triangle divided by QR of the second triangle. That is SAS similarity. Two triangles are said to be similar by SAS similarity if one angle of one triangle equal to the angle of the other triangle and the sides including the angle must be in the same ratio or they are proportional. Here in this case angle B equal to angle Q and AB by PQ equal to BC by QR. Then we can say triangle ABC is similar to triangle PQR by SA similarity. See an example here. Here angle A equal to angle P, both are 60 degree and AB equal to 8, AC equal to sides including this angle are AB and AC. One is 8 and the other is 6. Here angle P, PQ and PR are the sides including 60 degree. Okay. So here angle A equal to angle P, then take the ratio. AB by PQ, not it is not congruent, similarity. So take the ratio. AB by PQ equal to 8 by 4 equal to 2. BC by AC by PR equal to 6 by 3 equal to 2. Here you can see the ratios are equal. AB by PQ equal to AC by PR and angle A equal to angle P. So triangle ABC similar to triangle PQR by SAS similarity. Okay. And see, in the following similar triangles, write the ratio of the corresponding sides. Already told you how to write the ratio of corresponding sides. When you write the ratio or when you name the similar triangles, we must be very much careful or conscious. So here triangle ABC, triangle PQR. Here angle A equal to angle Q, angle B equal to angle R, and certainly angle C will be equal to angle P. Okay, Means we can understand from here in this figure two corresponding angles are equal. Two pairs of angles are equal. So the two triangles are similar. That is why these two triangles are similar. So once if we understood the two triangles are similar and how to write the similar triangles, here we started with it. We have written triangle ABC. A, B, C. A means this 30-degree angle, B means 70-degree angle, then comes to C. Same way you have to measure. Sorry, you have to name the second. You are not supposed to name the second triangle as PQR if ABC similar to which triangle we have to write. Here started with the 30-degree. So here start with the 30-degree Q. Next we came 70-degree B. So here go R. Now next we have to write the third vertex QR P. Okay, this naming is very important. A, B, C, same way, starting with 30, then 70. Q, R, P. Or else, if you are naming the triangles as CBA, CBA. How do we name the other triangle? CBA. So it should start with the P, then go to 70, PRQ. We have to name like this. And if we name the triangle as BAC, BAC, then how we should name here? It will be RQP. The same vertex must come in the same place. See, here A in the first place, A is 30-degree. So in the next triangle, 30 degrees Q. So Q must come in the first position. Next comes B, 70-degree. Here R should come in the next place. So remaining third vertex in the next place. Okay, this way. Similarly here, triangle CEC, these two triangles are similar. This is 30-degree, here is 30-degree, 40-degree, 40-degree. So we can understand these two triangles are similar. So while naming, here it is written CAB, CAB. So C is 40-degree. So here we should start with the 40-degree. Okay, here we should, how is it, sorry, just check it. Here we should start with the, here triangle CAB. Okay, then please check whether it is written. Is it okay or not? Whether we should make any change over here. CAB, triangle CAB. Start with the C, then went to 30-degree, then coming to angle B. So same way CAB, start with the 40-degree, check it please, F, then come to 30-degree, then last one B. So how it should be named? So it should be named as, please you can write it in the correct way. How it should be named? CAB, it will be FDE. It should be named as FDE. That's the way we have to name FDE. So how it is how I said it is not correct. It is not correctly written at first. What happened here? So here started with 40-degree. So here also should start with 40-degree. So CAB FDE. Okay. So in the same way we have to write the ratio also. After getting the ratio, after getting the similar triangles, must write the ratio corresponding to it. And it is a textbook question. Diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at O. Using similarity criterion, show that OA by OC equal to OB by OD. The trapezium ABCD is drawn with AB parallel to DC. Okay, and the diagonals intersect each other at the point O. Then we have to prove OA by OC equal to OB by OD. This OA, OC, OB and OD are the sides of these two triangles, isn't it? This smaller triangle and this is comparatively bigger triangle. So that is what I marked here, triangle 1 and triangle 2. So if we are able to prove these two triangles are similar, easily we can write the ratio of the corresponding sides and we will be reaching the answer. We are reaching the required result. For that, check how can we prove the triangles to be similar. There is a similarity or a. It is enough to find a similarity or SA similarity, SS similarity. Using any of the three similarities, we have to prove the triangles are similar. Triangle 1 and triangle 2 are similar. Which is easier one I have already marked here. Angle 1 is an angle of the smaller triangle. Sorry, not angle 1. I did not mark angle 1. Angle, the red colored angle marked at the top is an angle of the small triangle, and red colored angle marked in the bottom triangle in the triangle 2. These two are equal. They are vertically opposite angles. So angle DOC equal to angle BOA. These two, they are vertically opposite angles. Then you see AB is parallel to DC. If AB is parallel to DC and if we consider it as a transversal, these two are alternate interior angles. Okay, that green colored angle represent alternate interior angle, and this green color angle is an angle of this smaller triangle, and this green color is an angle of this bigger triangle. Similarly, we can find these two angles also equal, but it is not needed. We need to get only two pairs of angles equal. In the smaller triangle 1 and triangle 2, we got DOC equal to BOA, vertically opposite angles, and OCD, this angle, equal to OAB, this green color. These two are equal. They are alternate interior angles. So we can say since the two angles are equal, triangles are similar by a similarity. And how this triangle is to be named? See, triangle OCD. O, red color angle, to green color angle C, then to D. O, C, D. Same way we have to name the other triangle. O, then to green A, B. Okay, it's triangle OCD similar to OAB. So once if we got triangles are similar, all the corresponding sides will be proportional. So if we name the triangles correctly, we need not go to the figure again. From here we can write OC by OA, one pair of side, equal to CD by AB, equal to first and last OD by OB. We can name the similarity like this. Okay, it is written OA by OC by OA equal to CD by AB equal to OD by OB. And see what we have to prove. Anyway, there will be the ratio of 3 corresponding sides. Okay, but here we have to prove only 2 corresponding sides. So select which one is needed here. So we need OA OC by OA and OD by OB. So we have selected and wrote this 2 implies we neglected that. We are not selecting that ratio because we have to prove it. So we have written OC by OA equal to OD by OB. Here it's reciprocal we have to prove, not OC by OA, we have to prove OA by OC. So just return the reciprocal, OA by OC equal to OB by OD. That's answer. Next problem. In figure, QR by QS equal to QT by PR. Angle 1 equal to angle 2. Show that PQS similar to TQR. PQS I shaded here, and TQR I have drawn with the red color. Look very carefully. PQS is the shaded triangle and TQR is the bigger triangle which is drawn in a red color. We have to prove these two triangles are similar. And how to prove those two triangles are similar? See, easily we can understand angle. If you mark this angle, see this angle Q. Angle Q is an angle of this shaded triangle and red lined triangle. Means angle Q is an angle of triangle PQS, same way TQR. Okay, means angle Q is a common angle, is a common for both the triangles PQS and TQR. So angle 1 equal to angle 2 is also given, which is angle 1. This is angle 1 and the small angle is angle 2. Okay, in between PS and PR there is a small angle. And here if we want to prove angle 1 and angle 2, angle 1 is a common angle. Let it be there. Here angle 1 is common. Angle 1 is there in both the triangles. Next, if you want to prove these two triangles are similar, since we got one angle equal in both the triangles, if we are able to prove side including those triangle are proportional, we can prove the triangles are similar by SAS similarity. Anyway, we got one angle to be equal. Now, if there is any chance, here we are given what? QR by QS. This QR means full length by QS, the side of the small triangle. Then, isn't it? QR means side of the red triangle. QS means side of the shaded triangle, equal to QT, side of the red triangle. But it is PR. If it is QP, we can easily prove triangles are similar by SAS similarity. So what to do then? Actually, QT by QP was needed. Instead of PR, QP was needed. And think, is there any chance to convert PR to QP? Actually, in the ratio, in the place of PR, we need to get QP. Then we can prove the triangle similar by SA similarity. And is there any chance to make PR and QP equal? See this one. PR and QP in this triangle. Look this triangle. In this triangle, angle 1 equal to angle 2. If in triangle PQR, if two angles are equal, sides opposite to them are also equal. So we can say side opposite to angle Q is PR. That PR equal to side opposite to angle R is PQ. These two are equal since angle 1. That is why we are given this angle 1 equal to angle 2 to reach this result. PR equal to PQ. See. We are given that QR by QS equal to QT by PR. So if we should get QR by QS equal to QT by PS, you need not write. Only for you to understand, I have written it. And let it be equation number 1. Actually, we should get it. Means we have to convert PR to QP. For converting PR to QP, we are given angle 1 equal to angle 2 in triangle PQR. PQ equal to PR. Side opposite to equal angles are equal. So, QR by QS, this ratio, QR by QS equal to QT by PQ. Why it became PQ? Because PQ equal to PR, PR equal to PQ. So, this PR can be replaced by PQ. After that, go to the triangle, go to the case once again. In the small triangle, angle 1 equal to in the big triangle, angle 1. That means angle 1 is a common angle. Angle 1 equal to angle 1. Then QR by QS equal to QT by QP. Okay. So, triangles are similar by SAS similarity. The same thing. Angle 1 equal to angle 2. QR by QS equal to QT by QP. So triangles are similar. Okay, that's all. Study the similarity criterion and study these two problems very well. Remaining problem we will be explaining in the next